Hey C Sharpers, welcome back. My name is Matthew, I'm the C Sharp Artisan, and this is the 9th video in my series on Azure Service Bus. Now, if you watched the second video, you remember I gave this example of an Indian restaurant where there's an order queue and the cooks are pulling orders off the queue in order to cook the food. So let's imagine that you're running this restaurant and you've hired one cook. It's a good cook, and this cook can cook one meal a minute. So as long as your incoming orders never exceed about one order a minute, you're going to be fine. The cook is pretty much going to keep up. People aren't going to have to wait too long for their food, and everybody will be happy. But let's say things get busy and you're getting 2 or 3 orders a minute coming in. Pretty soon, that cook is going to fall behind and people are going to get grumpy. So what do? Well, you hire a second cook or maybe a third cook. Now, if you've got 3 cooks and they all can cook one meal a minute, you've got a throughput of 3 meals a minute. And so you can keep up and everyone's happy. So in software engineering, this is a classic horizontal scale problem where you've got some software that works, it's under load, and so to handle the load, you create more copies of the software. You scale out horizontally to handle the load. So in this video, we're going to look at 2 different techniques for handling this. And one is going to involve multiple receivers, and the other is going to involve a single receiver that can handle multiple messages. This is a diagram of the first of the 2 horizontal scaling solutions I want to show you. I called this one external scaling because the scaling is really happening outside of your code. What you can see here is we've got a single queue and we are spawning multiple receiver processes. So this would be a natural thing to do. For example, if your receiver was deployed into a Docker container, which is maybe hosted in Kubernetes, and then based on queue depth, you can spawn multiple copies of the receiver, each of which is responsible for picking up a single message and processing it. So I want to just show you that this really does work and it's very easy to do. You might be wondering, well, won't they fight over the messages, or how do you know who gets which message? And it's really very simple. So let's go back to our C# code. This is basically our service bus processor from the last video. And all I've done here is added a little log message so that as we run multiple copies of this, we can keep track of which copy is which. So I've already compiled it. And what I want to do is I'm literally just going to run it as a standalone app, not through the debugger. So you can see this reader, which started at a minute 48, second 47, is sitting there waiting for messages. And now I've got my magic message sender. So let's just give it a message and watch it go. So we sent a message and it picked it up. If we give it 2 messages, it's going to pick them up. So now let's start a second receiver. So now we've scaled out horizontally and we've got 2 of them going. This one started at 48:47 and this one at 49:20. So why don't I go ahead and just hammer it? I'm going to give it 10 messages. Let's see what happens. Ready? Go. So what you can see is this one got 1, 3, 4, 7, 9, and 10. And this one got 2, 5, 6, and 8. Why? Not sure exactly. What we're assuming is that there's slight synchronization differences. Each one is listening, but of course that's just a tight poll, right? It's checking. And so they're probably slightly offset and there's little delays on when you get the message. So it's a bit random. You just can't guarantee which is going to get which. But the important thing is the same message is never delivered to two queues. So the service bus infrastructure is going to guarantee that for you. Now, if I just send a single message, okay, it went to the second queue. Great. And let's send it another 10 just to watch it because it's fun. And there they are. So this one got 1, 3, 5, 7, and 10. And this one got 2, 4, 6, 8, and 9. So there you go. It's really very easy to implement a multiple receiver architecture. And again, if we want to just quickly look at the photo or the diagram one more time, you can see here. We just did 2 of them, but that's multiple receivers. So let's shut down these receivers. So what is the alternative? What's the second option that I talked about? So not surprisingly, I'm going to call this one internal scaling. And this is a single receiver. So here we're going to have a single queue, and we're going to set up a single receiver, but we're going to use the receive messages method that you remember from the earlier video, which is going to allow us to pull a set of messages off of the queue and then parallel process them using tasks within C#. So I'd like to actually just code this up. It's going to take a little bit of time, but I think it's worth it to kind of see how this might go. So let's go back to our solution. And the first thing we need to do is we are not going to do a processor. So I can just zap all of that. We are going to do a receiver in this case. So let's say service bus receiver options. We're going to make new receiver options, and I'm going to choose receive mode of receive and delete, just to keep it simple. So as soon as a message comes off a queue, it'll get deleted. I don't have to worry about completing it. And now let's create our receiver. Service bus receiver equals client dot create receiver with the queue name and the options. So now we have our receiver. Now I'm going to establish a long running process where the receiver is receiving messages inside of a loop. So for this, we can just do while true. And I do want some counters. So let's do an int loop counter 0 and task counter. You'll see how these come into play. So while true, now we're going to receive a set of messages. So this is going to be an I read-only list of service bus received messages equals receiver dot receive messages async. And let's say we're going to do 3 at a time. And let's do a little timeout here. Let's say time span dot from seconds dot result. So now we've got a set of messages. And actually, what I want to do here is log that out. So we'll say console.writeLine. We can do our string interpolation, and we can say messages.count received on loop counter. And let's increment it here. Let's say ++ loop counter. So now we've got multiple messages. And then for each message in the result list, we're going to kick off a task here. So at this point, to make this easy, I'm going to say, let's do a list of tasks equals new. So when we create the task, we're going to give it a delegate or a method used for running the task. And we can actually kind of just hijack our event handler here. So I'm going to change the method signature of this and we will write out the message body, but let's do a little better message here. So log the task counter, and then we can do the message body, and that should be a nice message. And we don't have to complete it or anything, and since it's not in a processor, I'm just going to change the name. So this is our little task method. So now we can say task T equals process message async message and plus plus task count. And then tasks.add T. So now we have a list of tasks, and we'll wait for them all to complete. So we can say task.waitAll tasks.toArray. And for this to be watchable, I think we need to put a little sleep in here. So we'll do thread.sleep just so you can see what's happening. That's a lot of new code. But basically, just to review it before we run it, let's make sure it builds. So we are establishing kind of a long-running process loop. And inside of that loop, we're going to check for messages and wait 5 seconds and then loop again. And if we get 1, 2, or 3 messages, for each of those messages, we're going to launch a task here to process the message. And then we're just going to wait for them all to complete, and then we will loop back again. So once again, we don't have to run this through the debugger. I'll run it compiled. And why don't we give it a bunch of messages to start with? So I'm just going to put a good, healthy number here. Let's put 20 messages in the queue. And let me run the tester. So let's just let it run a little, and then I'll talk about what's happening here. Okay. So on loop 1, we received 3 messages, and you can see the 3 messages processed in parallel. Now you may be wondering, you said, well, it didn't look like they actually went in parallel. They went one at a time. And that is a little bit of an artifact of how thread pooling is working here in this console app. But in a different environment where we actually had access to multiple cores and multiple threads, it would be parallelizing these. So, right, it just happens to run them all in the same managed thread because of the way this project is set up. So we get 3 messages processed, and then it loops, and it finds another 3, and it loops, and it finds another 3, it loops, it finds another 3, and then there were only 2 left, and now it is sitting here waiting for more. So why don't we give it some more to chew on? And we can say, here you go, why don't you have another 5 messages? And what's interesting is on the very first time, it'll get 1 message because it happens real fast, and then it picks up 2, and then 2. So sometimes because of the speed of processing, you're not always going to get 3 messages. Okay, and again, to look back at the diagram, we were doing internal scaling, where we have a single queue, a single receiver that's getting batches of messages and then dispatching them out in multiple tasks. 2 approaches to the same problem. They both work really well. And in fact, I've actually deployed in production code a hybrid where our basic receiver app was able to handle a configurable number of internal tasks or threads. But if we got really hammered, then we were using Kubernetes to spawn multiple copies of those based on queue depth, and so that it would kind of ramp up pretty quickly. So you could get 3 tasks in parallel, then 6, then 9, then 12. And it works really well. It stays nice and quiet during normal operation, and then if there's a boost, it's able to scale up pretty quickly. So there you have it. Horizontal scaling with different techniques in Azure Service Bus.